items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your question to our speakers. All questions will be captured, so if we don't get to answer you, we may follow up by email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulty, please click on the yellow Help widget with a question mark. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. You can find the survey in the red widget at the far right bottom of your screen. You must click into the survey. It will not pop open on your screen. The survey will only take a minute, and your feedback is extremely helpful. An on-demand version of the webcast will be available approximately 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Heavy Reading Senior Analyst Gabriel Brown. Gabe?
Okay, and hello everyone, and welcome to today's webinar, 6 Myths and Truths about Virtualization in the Mobile Core. Thank you all very much for coming. We're going to be looking today at mobile network operator motivations for NFV and at how they might make the migration from a classic appliance-based networking to a more of a virtual networking model. Specifically in the second half of the session, we're going to be addressing performance testing in a virtualized environment. The myths and truths angle, sort of inherent in the title here, is something we're going to be using really to sort of summarize a bit of a discussion between the guest speaker and myself towards the end of the session. This will really help to underline why performance testing in NFV is different. We certainly hope you find the session informative, and we very much appreciate your time and attention today. The webinar is broadcast by Light Reading, and as you just heard, is sponsored by Ixia. My name is Gabriel Brown. I'm a senior analyst with Heavy Reading. I've covered mobile networking and the mobile core as an analyst for some years now, and over the past 18 months or so, this has obviously included NFV. In fact, virtualization, software configurable mobile core nodes, different multi-standard nodes, and so forth, actually go back quite a long time in concept. NFV is, in some ways, it's a big jump, but a logical progression of what had been happening in the market, as it were. I'm going to be your moderator and host for today, and I'm also joined by our expert speaker from Ixia. That's Pierre Lynch, who is Senior Technical Product Manager in the wireless group there. Welcome, Pierre. Could you introduce yourself, please, for the audience?
Hi, Gabriel. Thank you. Yes, I'm Pierre Lynch, and I've been working for Ixia for about 8 years in the testing division of Ixia. And my responsibilities have always been in the wireless side. I'm a Senior Technical Product Manager now responsible for strategy.
Thanks, Pierre. And so once Pierre's taken us through the various bits of material and things we have pre-prepared, there is going to be a chance to ask him and myself questions. So do take advantage of that via the box and on your screen, the Q&A tab. You can ask us questions at any time, and I'll collect those as we go through. Any really good ones or particularly apposite ones, I'll try and work in if possible. But do take advantage of that if you can. In terms of agenda, it's quite simple today. It's quite simple. We're going to start with an introduction and status update on NFV and the mobile core. That'll be from myself at Heavy Reading. We'll then move on to a section from Ixia entitled Ensuring Successful NFV Migrations. We'll close on the myths and truth device as talked about, and then move to Q&A. As I mentioned, do take advantage of the question box. I will, if I can, try and work a few into Pierre as we go along. Not that I told him that before we got on the call, but I think that'll work quite well if you can. So with that, let's get started. The chart here is really showing a survey of a number of mobile operators we carried out last year. I think 70 mobile operators, something of that order. So it's a very good sample size. It shows I think really that a leading group of mobile network operators are today already starting to think about how to sort of implement and deploy NFV. You can see on the chart here 17% say they have a plan to start implementing and deploying commercially in the mobile core already. Potentially that's a little bit ambitious, but it does depend very much on your definition of what is a virtualized function or NFV, or even the term pre-NFV we're starting to hear now. When you really poke around, you find lots of operators have done something or other in this domain already, so conceivably would qualify. You also see a good proportion of operators that are definitely thinking hard about use cases, and perhaps have started some proof of concept trials, 36% there. Almost a mirror image really of those who have started thinking about it, but still very much in the early phases, and those that haven't really done all that much at all. I think you could sort of debate the timing a little bit, but I think that's pretty representative of where the market's at today. Basically, there's very strong interest in NFV. Of course, the challenge is turning it commercial. I'd really characterize 2014 as really a year of, if you like, functional testing of proof of concepts and some early field trials, potentially as operators look to move into some commercial deployments in 2015 and 2016. So with that, I'll move on to the next slide. One of the sort of questions is, mobile core in general is, where do you start? I've just done a kind of high-level categorization here, split it into 3 categories. The first is what you might call the control plane nodes. They are circled in yellow here. These seem in many ways an obvious place to start. Typically they're already kind of run on Linux, x86. Primarily Intel type platforms, of course, and from a sort of technical perspective, it seems like a pretty obvious place to start. One of the challenges, however, is that these are generally very, very critical nodes. Something like an MME, for example, while it sort of makes sense from a technical perspective, I think operators are quite risk averse in that domain. Although again, as solutions mature, we're seeing some virtual MMEs come to market as well now. Probably in the first instances, it will be things like policy servers, PCRFs, and things like IMS application servers for RCS and TAS for VoLTE and things like that. Down in the data plane, there's the S gateway, P gateway, SP gateway, and perhaps some of the other functions, DPI and such like. These are kind of received a lot of attention. The challenge here essentially is getting performance and stability that you need. One of the things we'll talk about is how you do take a performance hit with virtualized solutions today, but actually you can do a pretty decent job with this technology. I think here we'll probably see some of the first applications will be parallel deployments, so a particular EPC instance deployed for some particular use case. The classic one that everyone talks about is machine to machine, for example, which may not need high throughput performance. I think we could see a number of these kind of parallel applications of virtual core as a way to introduce it with as operators kind of move to a cap and grow type strategy. Keep the classic core for the main consumer mass market internet and start experimenting with some more advanced use cases. Then the other area I talked about is what I call the SGI LAN here, otherwise known as the GI LAN in 3G. I've just kind of split it into 2 different sections. Somewhat arbitrary as to what you might include in here, but basically there are a number of functions that are typically deployed in this part of the network between the packet gateway and external networks like the internet or cloud service providers and so forth. The challenge here really is it can be a challenge of where you have a deployment of various appliances from different vendors and the need to integrate all of that and the operational overhead that comes with it. It can be hard to make. Because of the tight integration, you have things like in-band signaling and lots of things like that make it quite hard to change. And the outcome of this is it makes it more difficult for operators to explore, if you like, monetization opportunities. The idea then really is to virtualize these functions and sort of run them as it were in the cloud. I think One of the reasons this appeals is it's the kind of off 3GPP nodes. So it's non-3GPP nodes that are perhaps a little more forgiving, and if you have a problem or such like, it's it's not as critical. The idea, as I mentioned, the idea here is really to virtualize functions, take the hardware appliances and sort of run them in the cloud, the telco cloud, as it were. And then potentially you can start routing specific service itineraries on a sort of per flow, per user, per company type basis through different service chains according to what you might need. These types of solutions are in trial now. I think we'll probably see commercial availability in 2015, early commercial availability then. I think there's lots of potential here and a good number of challenges as well. Things like flow identification, flow mapping, and so forth are all kind of works in progress, but nevertheless a good place to start. So thus far I've talked quite a bit about the applications, but NFV is also very much platform driven, and primarily you could argue it's a platform play. You get more of the benefits as you move more VNFS applications and workloads onto what you might term an NFV cloud type platform. The idea here is really to create something that is horizontal across the network, across the business, and can scale according to the different applications and workloads you put on it. It saves having all the OpEx associated with sort of different vendor platforms and so forth. In practice, I think there's probably going to be quite a bit of co-development between an application-driven approach we talked about and also the platform-driven approach, essentially so that you can start with functions that are easier to virtualize and move to this platform, and then over time add more demanding workloads. So in the next chart here, I'm just showing some examples of in fact, only sort of really publicly referenceable virtual EPC evolved packet core examples. These are things that have happened really over the past year or so. One of them's a little older than that. Typically, they're sort of obviously, by nature, they're quite small scale, but you can see there are a good number of them. This isn't including anything related to IMS and so forth. So far, from what I can gather, speaking to the operators involved in these trials and some of the vendors as well, the results are generally pretty promising. Certainly encouraging enough for operators to move ahead and move to next phase trials and so forth and so forth. In fact, I think one of the first commercial launch was actually already taken place, albeit again on a very small scale deployment in Myanmar or Burma by a redo there. So certainly, anyway, plenty of cause for optimism. Just before I hand over to Pierre for the rest of the session, I will also kind of make the point that we need to remember that NFV is basically a new technology or a new group of technologies applied in a new way from the perspective of a telecom operator, mobile network operator. Certainly, it looks achievable, as I said, but I think to move into the mass main production network, the technology obviously needs to improve somewhat from where we are today. I think it really needs to get to a point where operators are, even if it doesn't supersede the classic model on a sort of like-for-like basis initially, I think it needs to get to a point where operators are very sure that they can see a route to which they will end up with a much better platform and performance than the alternative. From there, they can kind of catapult and leapfrog as they move ahead. I think it's worth pointing out that the performance of the, if you like, classic solutions continues to improve. Many, in a mobile core context, some of the platforms are kind of old and legacy and so forth, but many of them, particularly in EPC, are very new and high performance. There's also a number of changes in that model as well, in the sense that, all right, you still have relatively long release cycles in terms of platform upgrades on hardware and such like, but within that, there's vendors have gotten a lot better at delivering shorter software update cycles within the long platform cycles. So that also is a path that's not standing still. So it's very worth bearing in mind as we move on to the rest of the webinar to talk about performance. With that, I'd like to hand over to Pierre at Ixia. Pierre, please. By the way, before I let him have the microphone, I'll once again remind you, any questions, type them into the Q&A, and I'll be keeping an eye on them. Thanks very much. Pierre, over to you.
Perfect. Thanks a lot, Gabriel. I appreciate the very good introduction. What I'll take you through now is a slightly more technical, still high-level overview of what we've seen from our customers about how they're going about and how we recommend to help them for the successful NFV migration. And this is, we didn't make this up. This truly is from our customers, and we've been involved for quite a while now, and so have our customers. So we've gained a little bit of insight into this and hopefully be able to share that with you. So one of the first things that we've learned is that even though the NFV with software-defined networking, SDN, the promises are real. The benefits that can be realized using this technology are real, and they're substantive. The cost savings, both for OpEx and CapEx, are significant. The things like elasticity that I'll deal with a little bit later, and agility, are just features that are inherent to virtualization. Agility, things like being able to spin up a service much quicker than in the past because everything is software-based and less coupled to the hardware. The elasticity, being able to respond to demand and capacity demands, changing capacity demands, and expand and contract the capacity over the same cloud in order to reuse efficiently the hardware resources. So it is a compelling argument. The benefits to be had with NFV are significant and they're real. But what we found is every one of our customers always had some concerns, and they're thinking about things. Okay, what are the new things that become involved with NFV? Things like performance, because of the nature of the system, is a little bit less, it's not as easy to characterize and guarantee. Visibility becomes an issue, and I'll deal with that a little bit later as well, being able to monitor the traffic. The reliability is a must. You have to be able to deal with that. It deals with it differently. Will it be as effective as current models? And it also impacts how security is dealt with. So understanding these things is really, really important. We've learned that through our customers. And what it's led to is the fact that this will not be a wholesale conversion. Nobody's just going to swap a real EPC out or IMS out and swap in a virtualized. It will be a migration. It will be stepwise, incremental, through various paths, either platform-driven or application-driven, like Gabriel illustrated. Some functions are probably going to be logically first in line to be able to do that. Control plane applications, like Gabriel said, are natural in my mind. But what it will lead to is a quote-unquote blended network where there will be combinations of real elements and virtualized elements within one network, and then combinations of real EPCs or real IMS with totally virtual EPCs as well, so small little copies of each other in the machine-to-machine example, or a distributed environment that we've seen as well. So this is not going to be a total cutover. It will be incremental, function by function or platform by platform, and both will exist together for a long time to come. So let's go through this a little bit. Just a small introduction to what it is. The standards body most heavily involved for network function virtualization is ETSI, ETSI. I forgot to write it down, but it's the European Telecommunications Standards Institute. And they have a working group that's concentrating simply on NFV, and it has way over 100 members now, so there's very active participation. And they defined a high-level framework for how this looks, and you're looking at it now. So I'll describe from the bottom up, because it's more recognizable. At the very bottom, there's hardware resources as we know them. So compute resources, processing power, then storage and network. These are physical entities. This is computers and storage and disks and networks. On top of that, what's new is this virtualization layer. Now this is a layer that abstracts the real hardware below and presents to everything above it a virtual view of that hardware. And the point behind that, the main point, is to abstract one from the other so that the virtualization presents to anything that wants it virtual compute or processing resources as well as storage as well as network, such that you can replace the bottom hardware resources transparently, and the virtualization layer just takes care of making it look like just another hardware piece to the virtual layer. So it's a total decoupling, and that's one of the main goals of this. It's a decoupling of the software to the hardware. So instead of having specific functions like an MME with the software tied to very, very specific hardware that provides the compute and storage power for this, it's a decoupling where the MME becomes a software package that can be run over a variety of different hardware types. That's the main goal. That's the idea behind virtualization. So what I've just described is the NFVI, or the NFV infrastructure. So that provides services to what's on top, the virtual network function. Now the VNFs are literally virtual machines, and these can be all types of different functions, a little bit as we know them now. One VNF can be an MME, the other one can be an S gateway or a PCRF, the policy, the charging, the home subscriber subsystem, etc. So these VNFs, there can be many of them, there can be little of them, and they can dynamically change. And I'll go through that a little bit. And then to the right is a very important part, is the management of all this and the orchestration. So somebody needs to manage and orchestrate how all these things work together, how they grow and how they expand and contract, etc. So this is the framework. This is the high-level framework that Ixia provides. Now I'll go through a few other details where I'll start putting some more real terms to this, and I'll start up at the top right corner going clockwise. So part of the management and orchestration is the virtual machine manager. So that manager is responsible for starting and stopping new virtual machines, instances of them dynamically, and then copying them if need to be on a different platform, and all of that is controlled by the orchestration and management. This management and orchestration also communicates to the existing management systems of the network and should be transparent as a requirement. So whether the existing OSS BSS is dealing with a virtual function or real legacy or hardware-based function, it should be totally transparent. And then going to the network function, there's a lot of emphasis put on things that we already know, but the emphasis is placed on the drivers and the network interface cards, the NICs. And all of a sudden there's a lot more pressure because they're the input and output to the real world, to and from the physical world for all these functions. And we've found that a lot of our customers are concerned with literally the drivers and the NICs there that can impact performance in one way or the other. The compute, you'll hear the term COTS, COTS hardware. COTS stands for common off the shelf. And that, again, is the point. These are generic servers. They can be built by a variety of different suppliers, but they are not tied to the functionality. They're not tied to the software. This is generic computing power, very high-powered stuff, of course, but it's just not specific to the functionality. You'll hear this term. The virtualization layer introduces things like hypervisor. The hypervisor is the implementation of this virtualization. And those, common names for that are VMware and Parallels that I run on my Mac, etc. Those are all hypervisors. The vSwitch becomes a brand new concept because it is a virtual software implementation of a switch that will switch traffic between one VNF and to another horizontally, they'll call it, the east-west traffic, so that VNFs residing in the same cloud will talk to each other. This needs to be switched. Then new concepts come into play like the elasticity, and this is really cool, where if suddenly demand, performance demand for a certain function increases, the VNS can be new virtual functions, new virtual machines can be instantiated to satisfy that demand, and it's done dynamically. So you need more MME power. I'm simplistically using that as an example. You just fire up another or more MMEs. You update all the DNS systems, of course, and update the networking, but all of a sudden you've got more MME power to satisfy the current demand, or all of a sudden there's a spike. And then when the demand for this performance goes down, you contract it again. You spin down those functions and take them away, such that the platform can be reused efficiently by some other function that may need suddenly more power as well. Very, very powerful concept introduced by virtualization. And then also service chaining that Gabriel described earlier. What this is, Ixia describes it as forwarding graphs. To me, the forwarding graph is a representation of a service chain. And it's basically, it's something that exists today, is a service to go from source to consumer will pass through different functionalities through the network. But typically you don't have as much flexibility in defining what that chain, what those elements are that are involved in the food chain involved from delivery from source to consumer. While as virtualization allows much more flexible and precise definition on a per service, per user, like Gabriel said, basis, where the packet flows or the information flows could be a variety of different types of service chains that you can much more easily define using technologies like virtualization that you could with today's hardware-based networks. Again, very, very powerful feature enabled by virtualization. So let's get into something else that I think is really important is, does this change the requirements? Does this really change what that network needs to do? No, it really doesn't. The end-to-end quality of experience requirements stay the same, exactly the same. So as a baseline, a virtualized network, a virtualized function, a virtualized thing must perform as well or better than its legacy or hardware-based counterpart. That is crucial to understand. It doesn't change a thing. So you validate and you make sure things work just like they did before. What does that mean? It means performance. It means service availability. It means the ability to deliver all the services, the video, the data, the voice services, service integrity and reliability and retainability, and also the robustness and resiliency, because virtualization, it changes the way that redundancy and service redundancy and functional redundancy is implemented, and it has to do it just as well as it did before. All right, let's get into a little bit more specifics. What does this look like? What does the migration look like? So from start to finish, you start with getting to know what you have now, and it becomes the baseline on the left side. So you test and you make sure this is what my network can do now. This is what my function, my individual function, if I'm looking at it, what is that granular, what can it do now? Assess it, test it. And at the end, you do the same. You confirm it. Did you get to where you wanted to go? Are you getting the same QoA, same service availability, retainability, et cetera, everything I went through on the last slide? And you got to verify that. You got to make sure that it is doing that, and that's simply by testing. In the middle, there's intermediate phases where you do plans and you do tests, security, monitoring kind of implications as well, optimizing, and this is a little bit of a cycle. And so for each and every either virtual function or whatever you're looking at to virtualize, whether it be small, medium, large, you go through this process of establishing a baseline at first, verifying at the end, but then an optimization phases during the migration phases in the middle. But that also leads to a little bit of a higher level concept, which is shown in the diagram at the bottom, which is, I call it the validation and regression cycle, where when you introduce new features, this is basic testing. You introduce new features or hardware changes, which is a new feature. Anything new, you validate. You got to make sure that it validates those features. You make sure they work exactly as expected. Your expectations are met, okay, and assumptions are verified. But then the other part is when you introduce new things, you got to make sure that the old things, meaning the existing features, are not broken. And that's called a regression test. So you test the new features and you run the old test to make sure the old features or the existing features still work, and then it's a cycle. Because that new feature you just tested and validated becomes an existing feature, and it becomes part of the regression test going forward into time. And this is a constant cycle, and this is something we see all of our mature testing customers do. This is just how they do things. Every single one of them, I've never seen an exception. So getting a little bit more concrete now, what does it look like? So there's a couple of options. There's virtualization of the functionality under test, of course. This is what we're talking about. But there's two options. You can either still use a physical tester with hardware or not. And this picture shows, a high-level overview of if you use a physical test system. It's still the same old chassis-based system, very high-performing system on a bunch of blades that physically connect into the virtualized system using the hardware basis of that virtualized cloud through the network interface cards. It's simple. Somewhere hidden behind those are the virtual network functions or the virtual appliances, like this graph says. But basically, somewhere in there is a functionality that I can reach using the physical network, and I can test it that way. Those VNFs can be anything. It can be any type of feature or functionality. Now, the counterpart to that is to virtualize the test system itself. In this instance, there's no specialized hardware. So the virtual tester, shown in blue here, becomes part of the cloud. So the cloud, which contains the vSwitch, the virtual switch, the hypervisor, and of course the COTS hardware at the bottom. You've got your virtual network functions in yellow that are the objective of the test. Those are the quote-unquote devices under test. We're going to have to change that term going forward and call it functions under test. But the tester is part of the cloud in this case. It can be part of the same hardware platform or not, but it's in the cloud along with the virtualized functions. It is important to take note of if the tester is part of the cloud versus same hardware or not, because that can impact the performance of the VNS. The VNS under test, if they're running on the same virtualized hardware as the tester itself, it will be impacted. So that leads to decisions. When do you use a virtual test system versus a physical test system? And this is how we see it, and basically we've learned this from our customers, is that one of the main things is for very high performance tests, they still maintain that it's preferable to use a physical test system, because then the test system itself will not impact the performance of the virtualized system. They are physically separate. Plus, the hardware is known with it's a known quantity. We know how to do this. We have certain performance levels. So any scale and performance test, and especially the last one on the left column, if you have very high precision performance measurements. So our rule of thumb is if the precision of the measurement needs to be below a millisecond, the specialized hardware in a test system will help you out quite a bit more for that versus common off-the-shelf hardware. But virtualized test solutions are just so incredibly convenient. If it's a multi-person team, no need to do resource management on the test hardware. If I need to test, I just spin up a virtualized test system, and I'm on my way. That's it. I don't need to ask my neighbor if he's using it or whatever. It's just so convenient. It's part of the cloud, which means it could actually be, this is a new part, it could actually be deployed with the virtual functionality into the deployment cloud, and a pre-test or even during deployment, quick tests can be run to make sure everything is cool. And but then the con to this is that very high the latency measurements and performance measurements, is there any precision required? And then also this is not well, it could be recommended for performance testing as well if it's on a different hardware platform. So moving on, again, more precision. I'm digging a little bit deeper each time. Why are we talking about this? Where are these bottlenecks that our customers are telling us? What are the stress points? They're looking at 4 things. I'm starting from number 4, top down. So virtual machine. The virtual machine itself can become a bottleneck. And the reason is both the hypervisors and the OSs and the virtual machine managers, one of the points behind virtualization is that it's portable, is that hopefully your VMs can go from one hypervisor to the next without ever seeing a performance difference. So that can be part of the issue. A virtual machine is part of a bottleneck that people are testing. And then the communication bottleneck between the host OS, which is running on the hardware platform, and then the guest OS, which is running the VM, can be an issue as well. And that leads to the hypervisor and virtual switch bottleneck, which is, I think, one of the main concerns, is that the software implementation of a switch between virtual network functions, which is typically packaged along with the hypervisor, is something that has become the objective of many of our tests, as well as good old drivers and the NICs themselves way down at the bottom at the hardware layer. In conjunction with the vSwitch, we've seen a lot of attention being spent there, where just shifting one driver to the next, one NIC to the next, would dramatically impact performance, and it's a great idea to know that before deploying. Now, some examples for you. And my examples are entirely based on LTE, the Evolved Packet Core, and some IMS examples as well. So in this case, this will be a typical thing. As Gabriel said, and I repeated, some of the functions that will probably be first in the queue to get virtualized are control plane and database-based type of applications, such as the HSS and the policy server, the PCRF. So these are very good candidates. In fact, I saw a PCRF cloud implementation literally 2.5, 3 years ago. So, and they would sell it as, policy as a service. So these are great candidates for virtualization. So in this case, in yellow are the 2 systems under test, the HSS and PCRF. In this case, they are virtual. And we put together an example, in this case a physical test system, and in all my diagrams going forward, the blue will be the simulation while the yellow will be the device under test. Now, when I talk about test systems, okay, we connect, and our job as a test system is to simulate things. All we do is fake things. So we present ourselves and we replace a node in the network, and we talk to the next node, and we generate traffic, and we make believe to the system under test that we are actually real, and this is a real network, and then that allows us to test whatever we place under test. So in this case, we are replacing the core network, the packet core, the MME, the P gateway, and the S gateway. They have interfaces. The S gateway, actually the P gateway has an interface to the PCRF, and the MME has an interface to the HSS. And we basically make believe to the HSS and PCRF by replacing the entire the MME P gateway and S gateway, and place it under test. And then in this case, we chose to use a physical test system. And this is a common occurrence because again, it'll be a stepwise approach towards virtualization. HSS and PCRF are very common examples of the first in line. Another example is a total EPC. So the whole Evolved Packet Core is virtualized, and in this case, we inserted a virtual test system in blue towards the right, so it's in the same cloud in this case, and we're simulating towards, the MMES gateway, P gateway with the policy and the home subscriber subsystem as well. Everything in there is a virtualized system that can communicate with each other through the vSwitch and also can communicate with the test system through the vSwitch and the hypervisor below in the hardware. So the virtual tester in this case will simulate an eNode B, or the base station, talking to the MME, and then the internet, which is one of the packet data network in a generic case, talking to the P gateway. So this is an end-to-end full service test designed for high load if you want it, but this will place these two simulations in the virtual tester can place this entire system under test on the same cloud. Very highly convenient, very cool stuff. Another example here, which will be a common one as well, is the fact that under test, there will be little instances of total virtual EPCs as residing and living alongside the real quote-unquote legacy. I hate calling it legacy, it's too early for that, but the physical EPC. So the physical EPC is there on the top right. These are real machines, real hardware. The virtual EPC is on the bottom, and the reason we singled this one out is this will probably happen. That as the migration progresses, small copies, either in, like Gabriel said, for the specialized for machine-to-machine communications, not the very high throughput stuff. We've seen examples of just spawning a geographically dispersed EPC to satisfy people that are roaming in far away places. So they would spawn off an EPC in that far away place to serve them locally. And then again, we place this under test, and lo and behold, the physical and virtual EPCs will interact. So we are testing them together. We'll actually be able to, with this configuration, simulating base stations and again the internet, perform handovers from one to the other. We'll make them work together because that's how it will happen in real life. That's what will happen in the deployment scenario. And this is something you really need to understand and have no surprises by just validating. And it's simple. You just validate it beforehand. And my last example, the IMS, and it's very similar to the other one, physical, virtual IMS, same thing. In this case, we're simulating UEs, and maybe the PSTN to receive calls on the other side, but it's the exact same concept I just explained, physical on top, virtual at the bottom. So moving on. One last thing I want to leave you with is the fact of that virtual switch that I talked about earlier. That virtual switch exists within the hardware platform. It means that traffic will not be seen by the physical network. It's transparent. It's the east-west traffic between virtualized functions within the same cloud. The traffic simply won't go out the VNICs. It won't go out the network interface cards. So this becomes a little bit of a liability, and it becomes a little bit of a challenge as well. So there's no visibility, audit trail, and then simply monitoring. Everybody needs to monitor each and every interface for either debugging or tracing capabilities, et cetera, et cetera. So it's hard to monitor something that is blind to you. So for this, there is a solution. And this here, exceptionally, I'm talking about a virtualized network where there exist phantom taps or VTAPs that can exist. There's software implementations of taps that exists at the vSwitch level here as drawn a little bit small, I'm sorry, in this little green box over there. So you have a manager of those taps, and it pipes into the visibility hardware platform that also receives all the packets and all the traffic from the physical servers and the physical network, et cetera. So it's a capability that needs to be transparent. This monitoring platform, this visibility platform, needs to be able to see inside this vSwitch and see the traffic here and report it alongside and combined with all the physical traffic as well transparently, and all managed from the same spot again. So that's it for me. Gabriel, I leave it up to you now.
Okay, fabulous. Thank you, Pierre. We're just going to finish with our myths and truths section coming up. While we're doing that, have a think of some questions. We have some decent ones in here for the Q&A, so we'll be getting to that in just a moment. So in the kind of spirit of myths and truths, in some ways, a bit of fun, but also hoping to address some important topics as well. I'm going to kick off, and then Pierre's going to take the second one, and we're going to alternate like that until we've done all 6 of them. So in the first instance, the assertion is the performance of virtualized and appliance-based nodes is more or less comparable. Well, to that, I would say, no, not yet, not today. The classic solution, and like Pierre said, he didn't really like the word legacy there. I don't really like the word classic, but essentially brand new state-of-the-art platforms that have just gone into networks and so forth. But if you like the hardware-based solution on a sort of performance per rack or per chassis basis is still going to be superior in terms of throughput, reliability, and such like. So to that, we can call it a myth. And with that, we'll move to Pierre.
Does virtualization introduce new elements to include in a validation? Hopefully I was able to deal with that earlier. Yes, of course it does. Things like the hypervisor, the vSwitch, orchestration, the virtual machine manager, all are brand new concepts. Like everything is meant to implement the same service, but these are new concepts, new different ways to deal with it, and then new concerns pop up because of it. So this one becomes a truth.
Okay, let's move on to the next one. Virtualizing a control plane application is relatively straightforward. I think we said at the beginning, it's one of the target functions. A couple of people have asked questions about why that is. Well, actually, no, it's not. It's not straightforward. In reality, I think we see applications need to be either designed from scratch or redesigned as you port them over for a cloud-type environment. I think if you're just doing a straight virtualization, perhaps it's straightforward. But to port something to the cloud, to the NFV cloud, I think is quite a bit more challenging. So yes, it's doable, but it's not straightforward. So for that one, it's a myth. With that, back to you, Pierre.
All right, next slide here. Whoops, where'd it go? Hold on. Okay, here we go. Sorry about that.
There you go.
Now, mine is my favorite. The end-to-end performance KPIs are the same as with legacy specialized hardware-based network. Well, I dedicated a whole slide to this. The KPIs, at the end of the day, you have to measure, and you have the same expectations whether you're virtualized or not. The service delivery and the quality of it, the end-to-end experience must be maintained or better. So this is totally but true.
Okay, and the next one is kind of reversing some of the points I made earlier. Or in a moment, the assertion is you can't virtualize data plane functions to run on COTS hardware and expect to achieve adequate performance. In other words, you can't do the data plane, you need specialist hardware. In reality, that's not quite the case. I think I said earlier it's not necessarily equivalent on a like-for-like basis necessarily. But actually, in practice, performance is still pretty good. It can be very good. And there are a number of optimization sort of techniques, some of which Pierre discussed a little bit there. Things like dedicated hardware NICs using DPDK on the IO, SRIOV to pin the application to a core and such like that. I think actually there's a public document circulating. You can easily find it on the internet from Telefonica, where they've shown 80 gigabit per second throughput on a sort of single standard Intel blade is very possible. So I think we'll have to call that one a myth as well.
And
Yeah,
the last one being there are differences and trade-offs between using virtualized or hardware-based test equipment. And the answer there, I dealt with that a little bit earlier as well. There's pros and cons to both. The virtualized test systems are just very highly convenient. They're easily spun off. Multiple person teams can do it. It enables deployment testing, etc. But for outright performance measurements, very precise measurements, performance and stress testing, etc., hardware-based systems are still viewed by our customers as a little bit more valuable. So I hope you've seen the trend here. I seem to be the Boy Scout of the pair of us, and I only deal in truth. This last one is the truth.
Very good. Thank you, Pierre. So now we're going to move on to the Q&A section. Just before we do that, I'd note that Ixia has written a book, Demystifying NFV in Carrier Networks, and I do believe if you click the link on your screen, or that will pop up on your screen, you can download a copy or get hold of it. So let's move to the Q&A. Quite some good questions coming in. Thank you all very much. Keep them coming. Pierre, I had one for you to start with here. A question coming in: have you already seen both physical and virtual EPCs being tested together? I think a number of ways you could read this, but as part of the same core network, as it were, I guess is one way of looking at it.
We are about to see it. What we've seen is the testing that we've seen is still in the construction phases, meaning the NEMs, the network equipment manufacturers. We send them testing their virtual cores by themselves, about to be delivered to the operators, who will then put it through the paces with the classic or legacy or hardware-based EPCs. That's where we expected more to see it, and that, I think, is happening this year.
Okay, good stuff. Another question, actually. What is question is, how do you think virtualization and NFV will impact the kind of network monitoring and service assurance type functions that people need, and that market as a whole? I mean, some of that's very similar to what you were talking about in terms of getting visibility.
Exactly. The challenge is what I went through the last couple of slides. That's what we've seen, is the fact that now a lot of the traffic becomes invisible to the physical network. So systems will have to come up that have to be able to deal with that. So either virtualizing the taps or becoming part of the hypervisor. Virtual taps seems to be a well accepted solution right now. That is a software implementation of a tap that resides next to the software implementation of the switch, and that can relay those packets back to the visibility system and then filtered on to the monitoring systems. That is the first challenge that we've seen.
Okay, good stuff. Another question for you. If you use tools to tailor COTS, such as DPDK, to optimize the performance of a specific network function, then do you not create a hardware and software dependency again? That sounds counter to the goals of NFV. I think it's possibly something related to what I said, but Pierre, you also mentioned the performance of specific NICs as being very critical. Could you see a little bit about what you're seeing there, and
The NICs are a big deal, and that still is part of the common hardware framework and the driver as well. And then you're right, those APIs that come up. But the APIs, like you mentioned, will be there for any type of hardware, it seems. It seems counterintuitive at first, but it seems that the COTS platform will provide those APIs over whatever platform you have. It'll just be there, and it's up to the virtual network function to use it or not. That's how I see it, as still being generic in the sense that Etsy meant it to be.
Yeah, and I think there's actually quite an interesting discussion going on in the industry as to what extent the cloud infrastructure, the data infrastructure used for NFV will be similar or different to the infrastructure used, if in a general IT cloud or data center cloud type applications. Certainly, there's kind of a view emerging. I think we might see a sort of network optimized data center type platforms, which are largely vanilla and generic, but perhaps some optimized I/O and things like that. That's my opinion anyway. So another question, Pierre, perhaps give you a shot at it, and if you don't fancy it, I'll make a quick comment myself. Will there be a total change in the mobile core architecture to support NFV? The questioner doesn't go on to finish it, starts with an example. Pierre, any comments on that? I mean, is it sort of sensible, logical to just port an entire architecture and keep it the same?
There's a sense that I've seen that virtualization may give an opportunity to collapse or expand the 3GPP architecture, and that's true. For instance, collapsing S&P gateway together is one thing that I've heard expressed as part of virtualization. It still has to maintain the ability to talk to a 4NS gateway because of roaming cases, so the S8 interface, but it may be an efficient way to combine and reduce the processing required to perform certain functions if it seemed possible. Having said that, 3GPP specs have always been pretty flexible when it comes to that. They suggest functionality like S&P gateway. They provide no guidance as far as you can put them together, you can leave them apart. So this just gives the opportunity to exercise that flexibility, I think.
Yeah, I think that's a good point in the sense that 3GPP is essentially a logical architecture. I think I would basically agree with you there as well. There's certainly among, if you think about it, CTO types that operators, there's certainly a view that, as you said, perhaps the architecture collapses a little bit, or you take a different slice of the architecture according to your use case. I think it's early days, of course, as well, because obviously 3GPP has served people very well thus far, so be sort of reluctant to relinquish that. One of the questions here says, you mentioned Ixia standardization efforts. What is the current state of these efforts, and when can we expect practical standards to be released? So I'll give you that question, Pierre, but I think perhaps worth pointing out, in fact, that Ixia is not per se developing NFV standards, but frameworks and specifications. I think standardization still rests with the other particular bodies, if I've understood it correctly. But they certainly are doing frameworks, reference architecture, specifications, things like that. Any update on that particular workflow, Pierre, at Ixia?
As far as I know, that's their goal as well. I don't think they're going to get into messaging standards and things like that. As far as I know, right now it's still at a white paper architecture, pretty high level, and they're working on a level deeper to help people implement it. Standardization of the functionality will remain a 3GPP, of which Ixia is a member, of course, but so they're closely aligned. But there may be opportunities to standardize certain things later on. I don't know if Ixia will get into it, such as management interfaces, orchestration interfaces, et cetera, or the selection of them. Things that are outside of the scope of 3GPP. That's the only opportunity I would see.
Yeah. Okay. And then just in terms of where they're at, there are a bunch of quite a lot of activity going on through the umbrella of Ixia in terms of proof of concepts in particular. And again, if I understand it correctly, I think the group which was due to have wound up at the end of this year is looking at extending its charter because it's got a lot more work to do. With that, we've come to the end of the hour. Thanks, everybody, for your questions. Any of the sort of really good ones we'll endeavour to get to you by email. Thanks for sending them in. Just before I go, I would like to let you know that you should see a URL link popping up or available on the right-hand side of your screen. It'd be fabulous if you could take a few minutes to fill that in before you go. Can assure you we'll pay great attention to what you have to say, and hopefully it'll make future webinars better and more productive. With that, I'd like to thank Pierre Lynch at Ixia for providing us with such an informative webinar today. Thank you, Pierre.
Thanks, Gabriel. You're welcome.
And finally, I'd like to thank everybody in the audience for listening and paying attention. We very much appreciate it. So thank you all very much, and goodbye.